Welcome to qnawire.
So let's use Archimedes' principle and Newton's second law for part A. So for part A, we can draw the free body diagram. Going straight up would be the buoyancy force, and going straight down would, of course, be mg. We can say that applying the Newton's second law to the block, we have the sum of forces in the y direction equals the mass times acceleration in the y direction. This is equaling 0. And so we know that then the buoyancy force equals mg, or we can say that the density of the liquid times the volume that is submerged of the block times g. This would be equaling the density of the block multiplied by the total volume of the block or the object multiplied by g. G's are going to, of course, cancel out. And so we can say that the fraction of the volume that is submerged, so we can say volume submerged divided by the volume of the object would be equaling the density of the block divided by the density of liquid. Now, the fraction that is above the surface, we can say that then the volume that is above the surface divided by the volume, the total volume of the object again, would be equaling 1 minus the density of the block divided by the density of the liquid. This would be your answer for A. Keep in mind that if the density of the block equals the density of the liquid, then the block is totally submerged. It will float, but the block is going to be totally submerged. So the surface of the water would be at the top surface of the block. For part B, we can draw a small diagram. So we can say that if we have a block here, this would be the water. We can say that this would be the mercury. And this distance here would be D. This distance here, not drawn to scale, would be L minus D. And so we can then say that the pressure would be equal to the initial pressure plus the density of water times G times D in this case, plus the density of the liquid times G times L minus D. And we're going to apply Newton's second law to the block once again. We can then say that this would essentially give us that P minus P initial times the area. So this would simply be the force minus mg equaling 0. And so we can solve and say the density of water plus, times G times D plus the density of the liquid times G times L minus D. This would all be multiplied by A equals the density of the block times L times A times G. And so we can then say that A essentially and G divide out, and we can say that then this is becoming that the density of water times D plus the density of the liquid multiplied by L minus D equaling the density of the block times L. And so D would be equaling the density of the liquid minus the density of the block divided by the density of the liquid minus the density of water times L. This would be your answer for part B. For part C, they simply want you to actually calculate it. So we have D equals, this would be 13.6 times 10 to the third, the density of mercury, kilograms per cubic meter, minus 7.8 times 10 to the third kilograms per cubic meter. This would be divided by, again, 13.6 times 10 to the third kilograms per cubic meter, minus 1,000 kilograms per cubic meter, the density of water. This would be multiplied by 0.100 meters. And we have that D is equaling 0.0460 meters. This would be our answer for part C. That is the end of the solution. Thank you for watching.